Hello everybody, and welcome to Greg's Vintage Workshop, where I'm working to restore history one piece at a time. Tonight we're on part 2 of the PACO Precision Apparatus Company E400 swoop generator. And tonight we're going to be finishing up with the cleaning. We're going to restuff the electrolytic, replace a couple components internally, and basically finish it up a little bit, and we'll do the first power up. So without further ado, let's get started. So here's how the face dial turned out. I'm pretty happy with that. It looks pretty darn perfect. I'm very happy with how that cleaned up. So let's see now if we can work the same sort of magic on the front. What I used was I started out with my method antibacterial spray, cleaned it with that. Then I moved into this Blackfire Total Polish and Seal. This is what I had back in 2014, 15, 16, 17 when I had my Corvette. I bought for it. And then finished up with the wet diamond all finished paint protection. That's what I did on that dial, and that's what we'll probably try and do on this. Now I also plan on getting the B&C jacks changed, the Amphenol to B&C. And I ordered some caps. If you notice, this one had a little cap on it. This one, the cap was missing. So I ordered some B&C caps that will go back on the way the original caps went on, but they'll be B&C jacks. Make it easier for somebody to use this. As you can see, it cleaned up pretty darn good. Big difference in what it was before and what it is now. There's the new B&C jack there and new B&C jack there. I have the adapter that actually goes in this. So it's just a matter of me getting the knobs back on this thing and the face back on it. I'm still waiting on DigiKey for my electrolytic to show up. But basically once the electrolytic shows up, I can restuff that can, get that installed, and we can start putting this back together again. So I was in here poking around, checking components and such, and this great big old orange drop that was in here sat like that, but I couldn't read the value, and I tried hooking it up in circuit and I couldn't get it to read a value, so I pulled it out and it read 0.2, which is what it actually is. You see this, it says 0.2 is a 10%, 0.2 400 working volts. That's a monster. I looked at the schematic, and the schematic says it's supposed to be 0.25. Now, that's nothing to worry about, right, in itself. 0.2 versus 0.25. But I happen to remember that I had some from DigiKey that are 0.27. And 0.27 for a circuit to call for 0.25, even though I'm nitpicking at this point, is a little closer, and mine's good for 400 volts as well. Mine's 5% versus 10%. Look at the size difference in the original and the one I'm going to put in here. They're both 400 volt. This is a 0.2, this is a 0.27. And the schematic's calling for 0.25. So I decided I'm going to go ahead and put this one in. There's nothing wrong with this when I take it out of the circuit and check it. Now, granted, I didn't check it for leakage because I don't have anything I can check the voltage with. My PACO 950A would do it, except for the cat's knocked it off the shelf and broke it, and I haven't gotten back into it to figure out what all broke. But so I'm just going to go ahead and, since I've got about a half a dozen of these from DigiKey, I'm just going to go ahead and put this one in its place. Everything else is testing out perfect in it. The cover that I had in the rust remover turned out really good, but as far as from a rust standpoint, but I never could ever get the color match the same after I put it in there, so I just decided to throw some copper paint on it. I'll show you that here in a sec. There it is, all of its copper glory. Turned out pretty good. The fact it's already copper coated anyway is good. I just threw the copper paint out just to make it look a little bit better. Not needed, but made me feel better about it. So that's that. Let me get this new .27 cap in here. We'll be back. So I got the new .27 cap in right here. And I also replaced the two Amphenol style connectors with BNC. There's the one right there. The other one's on the other side. Okay, so I got my three 18 microfarad at 450 volt capacitors from DigiKey. So now I can stick these down inside there. Keep in mind that the short lead is the negative, as depicted by the marking here. I'm going to try and keep those more towards the center to start with, I think, so that I can wrap them together easier. There we go. Now I'm going to push those down in there further once I get my negatives tied together. I'll do that now. Get you back. Okay, I've got those in there, and I made myself a common lead to come up through that hole in the cap I was showing you. I've insulated all of the negative sections. I've also put a little bit of heat shrink on each of the positives, so there's no way anything can make any contact in there. I did a trial fit on it. It looked pretty good. I think what I'm going to do is go ahead and shoot some hot glue down in there just to make sure that that's still insulated through there. And then I'll go ahead and put a glob of hot glue on it and put the cap on. Okay, so there it is, all restuffed. I could just put it in there, bend that lead over, solder it to the case, and put the other wires on there. It should be good. I finished it off with some metal tape. It's okay. It's not the best job I've ever done, but somebody can tell in the future that it's been redone, so that works. I'll get it in. Okay, so I'm getting ready to check the three electrolytics. Remember, I put the 18s in there. I'm just going to connect right here to ground because we're soldered to ground to the chassis right there. Let's get it. There it is. Hopefully you guys can see that. It looks like 17.20 on that one. Let's move it to the next one. 17.0908 on that one. We'll move to the last one. 17.21118. So all very, very close. Very, very close. Alright, get this thing wired in. And we're almost getting ready to power this up. So as you can see here, I changed that Sprague Atom 0.1 microfarad capacitor. Now, it was probably perfectly fine, but because I could not test leakage on it, I just decided, you know what, I'm just changing it out. So I went ahead and I changed it out. It was, the one that was in there was 0.1 at 600 volts, and this one's 0.1 at 650 volts, so it is what it is. Better to be safe than sorry in my opinion, so I'm sure the other one was probably okay, but since I couldn't test it for leakage, then I just decided to replace it. I wasn't going to take a chance with it. I saved it. I still have it in my capacitors. At some point when I get my leakage checker fixed, then I'll be able to test it. But for now, we got it in there. All I got left to do is to put the power cord back in here, and I'll be ready to put some voltage to it. See what happens. Okay, so I got my new polarized line cord into the RF power supply box, and I did it with a UL knot that you can see through there. Okay, so now let me back it out and I'll show you what we're getting ready to do. I'll move this over. For those of you who have not seen my multi-function panel, this is it. I'll zoom in a little bit. So first thing we're going to do is we're going to plug the line cord into my electronic circuit breaker. That's variable AC right there. That's not through the circuit breaker yet, but we're going to put it through the circuit breaker. First we'll turn on the whole multifunction panel, and then we'll turn on the electronic circuit breaker, and we'll reset it. This one here is going to show the current through the circuit breaker and the power. The voltage is input voltage, which is slightly higher than, I don't know why it reads a little bit higher than my household current, but my household current normally runs about 128, which is pretty high. But this will be what we'll be looking at as we turn things on. So, since that's all on at this point, let me back you guys back out a little bit so you can see more of the whole picture of what we're doing. Hopefully you'll be able to read that voltage when it comes up. So I'm going to turn the sweep generator off. We got some heavy-footed people upstairs. Alright, so I just flipped that on. Okay, so we'll be watching the round one here for actual voltage, and it's not going to come on until we hit about 34 volts or so. So I'll turn this light off here and make it a little more visible. Yeah, there we are. Came on at 33. I'm going to take it up to about 44 volts and let it set for a minute because of the recap I did on the electrolytics. It's drawn about 50 milliamps. This scene right here, 6.2 watts. Alright, so we're still at 44. We'll turn this up to about 70. Or 70. 71. Pulling 110 milliamps right at the moment. 16 watts of power. Up to 130 milliamps. Power is leveled off at 17 watts. I see a power indicator light on the face of the instrument. 140 milliamps, 17.2 watts. Let's turn it up to about 90 volts. There's 90 volts. Pulling 210 milliamps, 220 milliamps, 26.6 watts. Power indicator bulb is brighter. We're not popping anything in the electronic circuit breaker. Might even see some tube glowing on this thing. Yeah, my 6X5, I see it glowing. Let's turn it on up. About 110 volts. There's 111 volts. 111 volts, we're pulling 350 milliamps, 41.5 watts of power. I don't see any smoke rolling out anywhere. Well, that's good. Go ahead and turn it on up to about 120. 122. And there's 122. Drawing 430 milliamps, 49.8 watts. Staying steady at 430 milliamps, 49.9 watts of power, 122 volts. You guys can see that. Now if we move down to the actual tool, you can see the power indicator light's on. And if we move you over here, you can probably see the tube with some glow on the top of it right there. So for first power up, it seems to be doing okay, no smoke. So I'm just going to let it set here for 20 minutes or so and see if anything changes. So it's been about 20 minutes and at 122 volts we're still pulling 430 milliamps and about 49.4 watts, no smoke. So I think we're doing pretty good here. I think what I'm going to do now, and I noticed it when I was looking at the cord earlier, I had changed this jack and this jack to B and C. I didn't change this jack because I knew I had the cord that came with it, which is right here. But the cord itself is in pretty crappy condition, and I'd have to rebuild the cord to keep it original. I'm inclined to go ahead and put a B and C jack in that too, because it'd just be easier to connect it to a scope. I won't get rid of the old cord and such, but I think that we'll go ahead and do the B and C jack.